In exercise 1, we're told that the owner of a small computer repair business has one employee who is paid an hourly rate of $22. The owner estimates his weekly profit, the money left after paying the employee, using the function p of x equals 8,600 minus 22x. What does the variable x represent the number of? In our function, 22 represents the amount of money per hour. X represents the number of hours that the employee works. The profit left over is 8,600 minus however much money the employee was paid. That's $22 times however many hours he works. The answer is choice 2. In exercise 2, we're told that Peyton is a sprinter who can run the 40-yard dash in 4.5 seconds. He converts his speed into miles per hour using dimensional analysis by setting up the ratios. One of the ratios is written incorrectly. Which one is it? To determine this, we begin by seeing which units cancel out. For example, the yards units cancel out. We also see that the minutes units cancel out. The seconds units also cancel out. Remember, when we cancel units, we cancel one in the numerator to one of them in the denominator. However, notice that here I have feet. Both of them are in the numerator, and so the feet don't cancel out. This fraction here seems to be a problem. If it were written the opposite, with the miles on the top and the feet on the bottom, now the feet would cancel, and we'd be left with miles per hour. And so the ratio that's written incorrectly is the 5,280 feet over 1 mile. Choice 2. In exercise 3, we're asked which equation has the same solutions as 2x squared plus x minus 3 equals 0. There are several ways we could determine the answer to this problem. Let's take a look at a few of them. First off, notice that each of the choices is an equation written in factored form. We could take the given equation and factor it. We want numbers that multiply to -6 and add to 1. Those numbers are 3 and -2. We go through the process of factoring, and we find that the factored form is x minus 1 times 2x plus 3. Looking at the choices carefully, I notice that choice 4 is the same equation, and so I can choose my answer, choice 4. Another option would be to take each of the choices and multiply them out, determine which one is the same as 2x squared plus x minus 3 equals 0. This is a bit more time-consuming, but it will also lead to the correct solution. When we multiply out the choices and look carefully, we notice that the choice 4 gives us 2x squared plus x minus 3. That means that these are equivalent equations, and equivalent equations have the same solutions. So again, the answer is choice 4. Another option is to look at the graph of y equals 2x squared plus x minus 3 and identify the zeros, or the solutions to the equation. We see that we have a 0 at x is -1.5, and we have a 0 at x is 1. Which other equation has the same zeros? We can look at the graphs. Look carefully, and we see that we have the same zeros for choice 4 at -1.5 and at x equals 1. And so choice 4 has the same solutions as the given equation. In exercise 4, Crystal was given $3,000 when she turned 2 years old. Her parents invested it at a rate of 2% interest compounded annually. No deposits or withdrawals were made, and we want to know which expression can be used to determine how much money Crystal had in the account when she turned 18. Let's see what we know. The initial value was $3,000. The interest rate is 2% compounded annually. That's an exponential function. A is the initial value, and B is the factor. The factor is 1.02, and so we can write the equation y equals 3,000 times 1.02 to some power. What power is that going to be? Well, the money went in when she was 2 years old, and it was taken out when she was 18. That means the money was in the account for 16 years, so the exponent is 16. Look at the choices carefully. Choice 1 is 3,000 times 1 plus 0.02, that's 1.02, to the 16th power. And so choice 1 is our answer. In exercise 5, we're given 4 tables and we're asked which one represents a linear relationship. Again, there are a couple of different ways we could approach this. One option is that we could put each of the lists into a list and spreadsheet in our graphing calculator and take a look at the scatter plot. Take a look at the choices when we do that. We notice that many of the choices appear to be exponential in nature, but one of them, choice 3, appears to be linear. That means choice 3 is our answer. That's the table that represents a linear relationship. You could also identify this by looking at the patterns within the table. A linear function has repeated addition, adding the same amount over and over and over, equal differences over equal intervals. If you look at the first table, you'll notice that a different amount is being added to the y column each time. 1, 2, 5, 7. That's not it. In choice 2, each time we're multiplying by 2. 1/2, 1, 2, 4, 8. That's exponential. In choice 3, we have an addition of 2 each time. Plus 2, plus 2, plus 2, plus 2. That's linear. And in choice 4, plus 1, plus 1, plus 7, and plus 19. That's not linear. And so the answer is again choice 3. We identify this because we have equal differences of 2 over equal intervals of 1. That's a linear function. In exercise 6, we're asked which domain would be most appropriate set to use for a function that predicts the number of household devices in terms of the number of people living in the household. We predict the number of devices in terms of the number of people. The input is the number of people, and the output is what we're predicting, the number of devices. Input is number of people. Let's think about this. Choice 1 says the integers. That's the negative and positive whole numbers, -3, -2, -1, 0, 1, and 2. It's impossible to have a negative number of people, so choice 1 doesn't make sense. Choice 2 is the whole numbers, 0, 1, 2, 3, 4, 5, etc. As far as a number of people go, that makes a lot of sense. Choice 2 sounds like a good candidate. Choice 3 says the irrational numbers. Examples of irrational numbers are the square root of 2, pi, etc. I don't know what pi people looks like or the square root of 2 people, so choice 3 doesn't make any sense. Choice 4 suggests the rational numbers. Some rational numbers would make sense. 0 people, 5 people, that makes sense. But rational numbers also includes negatives and fractions. -3, 1/2, and it doesn't make sense to have -3 people or 1/2 of a person, and so choice 4 does not seem like a logical domain. Of these choices, the whole number seems like the best choice, and so choice 2 is our answer. In exercise 7, we're given an inequality, and we're asked which of the choices is equivalent to it. Let's solve the inequality. I notice that I have a fraction, and the easiest way to deal with this is to clear the fraction. Multiply the entire inequality by 3, and you're left with 21 minus 2x is less than 3x minus 24. Now let's solve for x. We can subtract 21 from each side, subtract 3x from each side, and we have -5x is less than -45. Now, be careful. We need to get x alone, and so we divide by -5. When we divide by a negative number, the inequality sign changes direction, so the solution is x is greater than 9. Choice 1. In problem number 8, we're told the value of a car is given by the equation v of x is $25,000 times 0.86 to the x. To the nearest dollar, how much more is the car worth after 2 years than after 3 years? That's an important thing to look at. Read the question carefully because we want to make sure we answer the question that's being asked. How much more is the car worth after 2 years than after 3 years? We take our function and we evaluate it for year 2 and for year 3. Then we have to find the difference. In year 2, we substitute in 2 for the value of x, and we find that the car is worth $18,490. Year 3, we substitute 3 in for x, and we find that the car is worth $15,901. Notice that both of the numbers we found for year 2 and year 3 are choices in the problem. However, the question was asking what is the difference between those two. We find the difference between those two by subtracting them. $2,588.60. And so 2,589 is that amount rounded to the nearest dollar. Remember, you could also use a table of values by putting the function into the calculator to find the value for year 2 and year 3. Whether you did it algebraically or you use the table, you find that the value for year 2 is 18,490 and the value for year 3 was 15,901 and 40 cents. Don't forget to calculate the difference to get your answer. In exercise 9, we're asked which function has the same y-intercept as the graph. The y-intercept is where the graph crosses the x-axis. In this case, it's the point 0, -3. There are several options for how we could solve this problem. Let's take a look at a few of them. First, remember when we have the y-intercept, the x value is 0. This is useful because we could take each of the equations and substitute 0 in for x to see if the y value is -3. When we do that, we see that we get all kinds of different y-intercepts, but only choice 4 has a y value of -3 when x is 0. And so choice 4 must be the one that has the same y-intercept as the graph does. Here's another option. 0, -3 is on the graph, and so it must be a solution to the equation that has the same y-intercept. We can substitute 0, -3 into each of the 4 equations and see which one is true. Notice that only choice 4 produces a true equation, and so choice 4 has that same point on its graph, 0, -3, and so therefore it has the same y-intercept. Another option would be to take each of the given equations in the choices and write them in slope-intercept form. We can look at the equation once we have it in slope-intercept form and notice the y-intercept. The y-intercept should be -3. When I look at the choices, I notice that the only one that has a y-intercept of -3 is choice 4. And so choice 4, once again, is our answer.